Craig Shambo. Craig, who is a very special friend and who I must thank very greatly for doing this, is the ABE GED HSED District Chair and an adult basic education instructor at Gateway Technical College in Racine, Kenosha, and Walworth counties. He earned a bachelor's degree from Carthage College and then his secondary education certificate at UW-Platteville. His teaching experience includes 2 years teaching math, language arts, and science in Galena, Illinois, 10 years as education director for EMS services in Milwaukee, 3 years teaching nursing recertification courses at Waukesha Memorial Hospital, 5 years teaching EMT paramedics at Gateway Tech, and 10 years teaching math and science for ABE GED at Gateway. His professional certifications include an EMT paramedic, firefighter 2, state certified MPO, and a fire officer. Now you know why I never worried about anything when Craig was in the building. Craig has some really wonderful philosophies about education, and they include, and I'm quoting, all students have the ability to learn anything when placed into the right environment. We need to prepare every student for the process of the lifelong learning, giving each the tools they need to be able to teach themselves. I love that. So Craig, I'm going to just turn it over to you to take it away. Thank you.
All right. And I want to welcome everybody. I'm going to start this off kind of how I start off all of my classes, and that's with an icebreaker. What I'm going to do is I'll be sharing a lot of my screens today, and I'll just turn my screen on right away. All right, and you can see that I just have a white sheet of paper. I didn't put up the whiteboard because I can change this out. I've also got a document camera that I use, so I can just change things out on the fly without needing to change from one to another. And the way that we're going to start out today is I'm going to be looking for 5 4-digit numbers. And I'll need 2 volunteers to raise their hand and supply with a 4-digit number. 4-digit number like 3, 6, 2, 7. All right, just an individual digit to fit into each of those 4 spots. All right, so we'll even add another number here, 2, 3, 4. And if somebody could raise their hand and supply us with a number, that would be great. Now, before we do, I'm going to write a number down on this piece of paper and put my name on it. And the time right now is 1:35. And you can see the time on there is 1:35. I'm gonna fold this paper up. And just so you know that I'm not doing any sleight of hand here, I'm gonna stick it right in my collar here. There it is, sticking out the corner of my collar. All right, so if somebody wants to raise their hand and give me a 4-digit number, I'll write it down in the seconds piece here.
So it looks like we have a number from Lois, which is going to be 8954.
All right, and I'll just add a 1 and a 0 and let's say 45. Another number. Madison, you're on mute.
Is it Joan over here that has another number?
Sure.
Go ahead.
5, 3, 8, 2.
All right, and for our final number, we'll just go with 4617. All right, so what we're going to do now is I'm going to add all of these numbers together. All right, so when I add the first column, I have 7 plus 4 is 11. 11 and 5 is 16. 16 and 2 is 18. 18 and 7 is 25. Carry a 2. 2 and 2 is 4. 4 and 5 is 9. 9 and 4 is 13. 13 and 8, 21. 21 and 1 is 22. 2 and 6 are 8. 8 and 9 is 17. 17 and 3 is 20. 20 and 6 is 26. 2 and 3 is 5. 5 and 8 is 13. And 1 is 14. 14 and 5, 19. 19 and 4, 23. So our number is 23,625. What I wrote down on this piece of paper, 23,625. Same exact number that we got. That's with random numbers that we added together.
That's incredible. How did you do that?
And that's a good question. All right. And my students, when I start a class off like that, it's to generate interest. They're now interested in how we added those numbers together, and I could predict what we were going to get. As long as they have that interest, they're interested in learning about how we're going to be adding numbers together. All right. So it's not a jar that I want to fill right away for my students, but in the end, we will reveal how we did that. All right. Now, what I did is I kind of took the topic that the presenter who was unable to make it today was going to present, and I kind of built something around that. All right. And I noticed that one of the first things she was going to talk about dealt with place values. And place values are very important to know. All right, because when we start talking about adding, subtracting, multiplying, dividing numbers, place value is going to be very important in how we explain that. So what I do when I'm explaining place value to students is I show them a representation just like we have up on our screen here, where we start out with the units. And then the units all have 3 numbers. They have the ones, the tens, and the hundreds. And then comes the thousands. Now, I was interested, as were my students, on how our number system, why it is we have commas separating each set of 3 numbers. And I'm not really a math instructor by trade, but I've taught some math in my lifetime. And the important point is I did stay at a Holiday Inn Express. So I can talk about some of this stuff with some degree of certainty. And what I tell my students is every set of 3 numbers is called a period. All right, so we have the units period, we have the thousands period, we have the millions period. The next set of 3 numbers is the billions period, then the trillions period. Then we would have, of course, because my students said, well, what comes after trillions? And I said, well, I'm going to have to look that up. All right, but it made a lot of sense because after trillions comes quadrillions, then quintillions, then septillions, octillions, nonillions, decillions, and it uses the Latin terminology, dec meaning 10, all right, illions, and probably the highest number now that I can pronounce would be up to centillions, which would have the number 10 with 101 zeros written after it. All right, so the naming of the numbers, but what it's not important necessarily for them to be able to name the numbers that are that high, especially since we're working primarily with the thousands and the units. All right, so what I tell them is when we see a number like 327, we would pronounce that 327. And there are no units that we would say after it because that is our units. But once we get into the thousands, we would pronounce that number by its period. So we would call that number 475,327. And similarly with all of the different periods that are there, if we had that number would be pronounced with its period 123 billion, 456 million, 475,327. So place value, very important. I don't start introducing the place values of the decimal system until we're kind of comfortable working with the place values of the whole numbers. Next, we'll talk about rounding numbers and how to round numbers. And I provide my students with this same type of handout, written a little bit bigger, but then we start talking about the rules. So I provide them with a handout that looks a lot like this, and we'll write a number down. $10,570, and we want to round this to the nearest 100. All right, so the first thing I have them do is I have them underline the number of the place value that we're working with. Since we're rounding to the nearest 100, I'll have them put a line under the numeral that's in the 100 spot. Then what I'll tell them to do in rule number 2 is point to the digit just to the right of the underlined digit. If that digit that you're pointing to is 5 or more, add 1 to the underlined digit. So I put a +1 there. All right. And then the next rule says if it's less than 5, we leave the digit that we're rounding alone. Okay. And the final instruction is to make all other numbers zeros, including the number that you're pointing to. So we're going to add 1 to 5, making it a 6. When we round to the nearest 100, we would have 10,600. So those rules are written right down for the students so that they can refer to them as we're practicing with numbers. Again, underline the number of the place value that you're rounding. If we're rounding to the nearest 1,000, we would underline the number that's in the 1,000 spot. Point at the number just to the right of the underlined number. If that number is 5 or more, we add 1 to the underlined number. When I add 1 to 7, I get 8. All the number that I'm pointing at and the rest of the numbers become zeros. And my answer would be 18,000. rounding numbers. Are there any questions? All right, then what we want to do is take a look at, and when I'm working with real basic students, I want them to understand our number system. All right, so I get an idea of what I'm working with, and if I'm working with somebody that's very basic, I want them to understand that we can write numerals 0 through 9 in any place value. All right, so in the ones area, and I often incorporate money here, all right, we can fit, and I use pennies. And I have a square there so that we can't fit any more than 9 in. So we can count numbers all the way up through 9. But when we go to add another penny, we can't write a 10 in the ones area. All right. So there's got to be something that we do when we add one more penny to this. And for every set of 10 pennies, they can trade that in for a dime. So now we have 1 in the tens area and 0 in the ones area. That's where our number 10 comes from. Then we would have 11, 12, 13, 14, 15, 16, 17, 18, 19. But when we go to add another 1 in here, we can't fit it in anymore. So we would trade our 10 pennies in for another dime. And now we would have 2 in our 10 spot and 0 in our 1 spot. All right, so that's how I get the students used to there being no more than 9 in any place value. All right, when we work with tens, tens being worth 10 cents, again, we can fit 9 in the tens area, but when we go to put another one in, it doesn't fit anywhere. We can only fit up to 9 tens. What happens when we try to add that 10th 10? Well, 10 dimes you could trade in for $1. All right, so $1 is worth 10 dimes, and 1 dime is worth 10 pennies. So then we go through some math and figure out that, wow, there's 100 pennies in $1. All right, so once we understand the number system and how it works, that's when I switch over to transitioning to addition. All right, so when I'm transitioning to addition, I'll say, what if we had 23 and we added 14 to it? So they had 1 set of 10 and 4 ones. And then they can see they have 3 sets of 10 and 7 sets of 1, counting up the 7 that are in the ones area. So that's how we begin teaching an introductory learner how to do addition. All right, I use a lot of visuals, and I have the students actually manipulate the materials that we're using. All right, so that they not only hear it from me, they can see it and they can be working with it. So they're learning in a lot of the different learning styles. All right, so what happens if we have 37. And we add 14. Well, we're adding one set of 10 and 4 more ones. 8, 9, 10. 10 doesn't fit in there, so I have to trade my 10 pennies in for a dime. 11. All right. So there we would have our answer, 51. So they can actually see by moving things around how our number system works and how addition works. And we go all the way up through using a dollar, all right? Once we understand addition, then subtraction I introduce right away, because now they have the concept of how our number system works, that each place value can hold up to numbers 0 through 9. Once you hit that 10th one, you have to add 1 to the next column and take all 10 away from the first. So if we had, in this case, 132, and we were going to subtract 94. How would we do that? Well, we have 100 32. All right, now we're going to subtract 94. We always start with the ones. So we're going to be subtracting 4 from our ones. Oh goodness, we only have 2 in the one section. We can't take 4 away from 2. But we know that 1 dime is worth how many ones?
10.
10 ones. So I can borrow from this dime and I can add 10 more pennies in the ones area. 2, 3, 4, 5, 6, 7, 8, 9, 10. There I've put 10 pennies into the ones area. Notice now that my ones area has more than 10 in it, because I just added 10 to it. All right, so now I can subtract 4 from the ones area. I've got enough in the ones area now to take 4 away. So when I take 4 away, 1, 2, 3, 4, I'm left with my answer. $128. And then we go through actually looking at it to saying, all right, we need to borrow from the 2. Then we work with the tens. We're going to take 9 tens away, but we only have 2 tens there. So again, we need to borrow. We can borrow 10 dimes from the dollar. We put our 10 dimes in. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the 3 that were originally in, or the 2 that were left. All right, so now we have enough dimes that we can borrow, or we can subtract 9. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're left with 3 dimes. when we subtract 94 from $1.32, our answer would be 38. All right, we borrowed 1 from the 3. That left us with 2. And the 10 that we borrowed, we added to the 2 that was already there, giving us 12. We borrowed 1 from the dollar, giving us 10 more dimes. Then we could subtract 9 from 12, leaving us 3. All right, so we use our number system to explain. Then we start adding numbers without using the manipulatives. All right, so we give them sets of numbers. All right, and I'll say, all right, add these two numbers together. Add 7 plus 3. And we come up with different strategies on how to add those numbers together. All right, some people will know what 7 plus 3 is. All right, some people will say, all right, I'm not quite sure how to do that. And I'll say, well, we could use manipulatives. It doesn't have to be pennies. We could use our fingers. If we start at 7 and add 3, we get 8, 9, 10. So we go through some of that. Then we give them double-digit numbers. And I'll say, take 27 and subtract 13. And I'll start out with numbers that they don't have to borrow from. They can just subtract straight down. We'll work our way then toward numbers that they have to learn to borrow. All right. Again, at the beginning, we're taking 7 away from 3, and they'll say, well, I can't take 7 away from 3. And I'll remind them that, well, if there's not enough, we can always borrow from our neighbor. All right, so we're going to borrow a set of 10, and we're going to add 10 to the 3 that we already have, making it 13. Now we have enough that we can subtract. All right, as we work our way forward in class, I'll read them a set of numbers. All right, instead of writing them down for them, I'll read them a set of numbers, and initially it'll be double-digit numbers. It'll work its way up to triple-digit numbers, and I usually don't go any higher than in the thousands. But what I want to gradually work toward is them writing a set of numbers for me, like 1,230, 754, 612, and I'll just come up with a set of 5 numbers. What I found to be the biggest problem that most of my students have is when I give them more than 3 numbers, they do one of 2 things, and some of them do both of these. They'll write their numbers as small and compact together as they can on the paper. I don't know if they're trying to conserve paper or what they're trying to do. All right, so I'll say in order to be able to see what you're doing, you have to add like place valued numbers. So we have to know which ones are our ones and which ones are our tens and which ones are our hundreds. All right, so they'll write their numbers small, and if they're right-handed, their number column will drift to the right. And if they're left-handed, their number column will drift to the left. So to combat that, what I do is I give them a sheet of paper, graph paper, where they can practice lining their numbers up. And I'll say, add 2,123 plus 572 plus 647. Using the graph paper now, we can see that we have all the ones lined up. So we know what we're adding to what. We've got all our tens lined up. We've got all of our hundreds lined up. All right. So we can work with lining up the place values. And initially I start out by giving them the place values again so that they know what we're lining up. And if somebody adds their numbers together and comes up with an incorrect answer, we'll throw this up there and see how it is they lined their numbers up. All right, students then get the hang of adding numbers that are in columns. All right, so then what I'll switch to in addition is I'll give them a set of numbers like 27 plus 16 plus 14,440 plus 327 plus 5. And I'll put them in a row like that. All right. And we'll talk about the fact that you don't have to add numbers across like that. You can change the numbers around to what you're used to looking at with the numbers in a column. All right. So all we need to do is write these numbers in a column. Now this is where they have problems lining up the place values. All right. Especially when they're trying to write 27, 14,440, let's see, 14,440. It's hard to get their numbers. So I leave these with the students, all right, so that they can go ahead and put the numbers into those columns. All right, so let's get rid of those. And let's put these in an order that we can work with. So we have 27. Oop. We have 27 plus 16 plus 14,440 plus 327 plus 5. Now I've got all of my numbers lined up. Some students can look at that and say, yep, I can work with those numbers. And some students look at those numbers and say, well, it's still kind of confusing to me to know exactly what I'm adding to what. So what I do for them is I say, well, you can always add zeros where there are no numbers, because we're not changing the value of the number by putting zeros in front of a number. Now they have numbers in all of their columns.
Craig?
Yes.
I just had a comment from one of our members, and we were wondering if we could use a different color than red just for continuing. It's a little difficult to see.
Sure.
Just for the next. Thank you.
All right. So then they can add those numbers together. All right. We're going to come up with a couple different numbers here. I'm going to use, we'll use a black. So 324, 17,430, 12, and 427. And we're going to add these numbers together. All right, so we'll go down the columns and we'll see how many ones there are. There's 4 and 2 is 6. 6 plus 7 7, 8, 9, 10, 11, 12, 13. All right, I'll have them write the 3 down. And the way I was taught, we come all the way up here and add 1 to the tens column. But more often than not, students respond to this. There I can see my 13 that I'm adding. All right, then I add the tens. 2 plus 3 is 5, 5 and 1 is 6, 6 plus 2 is 8, 8 plus 1 is 9. In the hundreds column, I have 3 and 4, which is 7. 7 plus 4 is 11. 11. 7 plus 1 is 8. 1 and nothing is 1. And there's their answer. So it doesn't matter if they put their number up at the top of the column or the bottom of the column, just as long as that 1's getting added in. All right. A lot of what I discuss with my students is you may have been taught one way in the past, and your teacher may say, if you don't do it exactly the way that I show you, even if you get the right answer, I'm going to mark it wrong. All right, and that's happened to a lot of our students. All right, what I tell them is what you need to do is learn a method that works for you, and you need to put that in your toolbox. All right, there's probably 4 or 5 different ways you can do just about any math problem. All right, so find the one that works for you, and this works for some. All right, for some, they're used to putting it up there, so they continue to put it up there, and that's fine, because that works as well. We see that we get the same answer. We go through subtraction and borrowing, all right? And we saw how to borrow in subtraction already. Okay, we'll have like 2001 minus 193. And this is always a fun one for students because they know that they can't take 3 away from 1, so they need to go next door and borrow, but there's nothing in the tens to borrow. So then they can't borrow from there, so they go to the hundreds and there's nothing to borrow from there. All right, they say, what are we supposed to do if there's nothing there to borrow? And I say, well, there is a number there that you can borrow from. That number is 200. We're going to borrow 1 from 200. And if we borrow 1 from 200, we get 199. And when we borrow a set of 10, that set of 10 goes in front with the 1s. And then we go ahead and subtract. Okay, just a quick side note here. If we had 2,000, and we had we were going to subtract 674 from it, you could go through the borrowing, and I always go through the borrowing with the students. I do the subtraction with the students. We get our answer. But there are other ways to do that. For example, when I have 2,000, I can make my 2,000 1,999. All right, I took 1 away from 2,000. So when I get my answer, I need to remember to add that 1 back in. All right, 9 minus 4 is 5. 9 minus 7 is 2. 9 minus 6 is 3. 1,325 plus 1, 1,326. Same answer as I got before. And I say when you manipulate numbers like that, I'm going to take 5 away so that it's easier for me to subtract, remember to add it back in at the end. And then I go through demonstrations like I did at the beginning of class, where I say you can manipulate numbers to do whatever you want them to do, as long as you undo the manipulations that you've done. So subtraction. With multiplication, multiplication is probably one of my favorite things to talk about. Multiplication is fun to talk about because there's so many nuances that go with multiplication that there's lots of tricks and tips, and I'm just going to set some numbers up here and show you how they work. Now, with multiplication, sometimes what I do to begin multiplication is I start my students out with something called skip counting. And not too many of them know what skip counting is right away, all right? But let's see here. Skip counting, what is skip counting? Who can tell me what skip counting is? Anybody? Skip counting, if I were to skip count by twos, I would count 2, 4, 6, 8, 10. Who can skip count by threes?
6, 9, 12.
Good. 3, 6, 9, 12, 15, 18. All right. Who can skip count by fours?
Joan?
4,
Mhm.
8, 12, 16, 20,
Good.
24.
All right. And we see that the fives and the tens are really easy for them. All right. So then we go through, well, if you're skip counting, if you're multiplying, you can skip count. For example, and I'm just setting up some tape on my fingers here to show you a real neat trick. If you were to take 3 times 2, you could skip count by twos 3 times. 2, 4, 6. That's multiplication. All right. If we were to skip count by fives and we had 3 times 5, 5, 10, 15. So I teach them how to skip count. And even my students that are in GED, I notice that some of those students have trouble multiplying numbers together. And it's not that they're lazy, that they don't take the time to memorize their multiplication tables. It's that we have students, believe it or not, that just like dyslexia, there's a disability called dyscalculia. That's the same thing as dyslexia, except it's with numbers. So when you have students that have dyscalculia, try to memorize multiplication tables. It doesn't matter how many days in a row they work on it. They cannot memorize those. These students often have trouble reading time unless the time has the numbers written on it. They can't read a clock and tell what time it is because numbers have no meaning to them. So we have to figure out alternatives for how these students with dyscalculia can work with numbers, all right? So in a lot of cases, I end up letting those students, and in some of their disability plans, it's written right into their plan that they need to use a calculator anytime they're doing anything with numbers. All right, so they've got a calculator in their hand all the time. All right, believe it or not, I had one paramedic student that had dyscalculia. That's before I even knew what dyscalculia was. All right, and in paramedics, we need to be able to calculate drug doses very quickly, like if we're working on somebody that's in cardiac arrest. We have to be able to do some of those multiplications in our head. And he needed to administer a drug that he needed to multiply 6 times 2 together. And I said, so how much medication are you going to give? And he said, 7. And I'm like, no, really, how much medication are you going to give this person? He's like, 10. And I'm like, are you just messing around with me? He's like, no, I can't multiply numbers. And I'm like, well, how did you ever make it through school? And he said, I always had a calculator in my hand. All right. Now he tells it that the teacher always put a calculator in his hand from when they started learning numbers in his school system. So that's all he ever learned was using a calculator. All right. But I have a suspicion that he probably had something else going on, like dyscalculia. All right. So while I've got the tape
I
on
just want to give you a 10-minute warning.
All right. So once we've identified to students how it is they multiply numbers, then I start in with some of these. So you can multiply any numbers 6 through 10 just by using your fingers. All right. Each of your fingers has a different number associated with it. So your thumbs have 6. Index fingers are 7s. Middle finger is 8. Ring finger is 9. And your pinkies are 10. We have those on both hands. So we have 6s, 7s, 8s, 9s, and 10s. Now, let's say we're gonna multiply 6 times 7, all right? So we line up our 6 finger and our 7 finger. Now, what we're gonna do is we're gonna count the 2 fingers that are touching, we're counting as a bridge. So we're gonna count the bridge fingers and any fingers that are above the bridge, all right? So when we put those together, we have 2 that make the bridge, our thumb is above. So we have 3, and then we multiply the fingers that are below the bridge. So we have 4 times 3, which is 12. 30 plus 12 is 42. All right, one of the tough ones, 7 times 8. Let's line up our 7 finger and our 8 finger. With the bridge and above the bridge, we have 1, 2, 3, 4, 5 fingers. Below that we multiply, 3 times 2 is 6. So our answer would be 56. 9 times 9. We have 8 fingers that make the bridge or are above the bridge. We have 1 times 1 below the bridge, which is 1, 81. So you can do all your 6s, 7s, 8s, 9s, and 10s times tables simply by using your fingers. One of the interesting things I found out about multiplication was we used to race in grade school with multiplication tables. All right, that's how we learned our multiplication tables, was by drill, 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 drill. And we'd get a set of 100 questions, and the fastest person done got to run up to the board and put their name on the board. And that was just the old method of doing it. And I tell my students I forgot to study once for one of my 9s tables. All right. So what I did was I wrote numbers down, and it seems like I can't share a screen anymore, but I wrote my numbers down. Oh, you're working on giving me a screen back again?
We can see your screen, Craig, or I can.
Okay. Let's see here.
I'm actually seeing the Zoom meeting.
All right, so I'm gonna stop sharing that one.
Okay,
And
that's good. That's good now.
with this
Now
one.
we see you.
All
Okay,
right,
here we
so
go.
I didn't study for my 9s
Here
times
we
table.
go.
So the teacher handed out the test, and instead of just sitting there, I decided, well, I might as well do something. So I wrote numbers down between 0 and 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I just did them in reverse order. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are the 9's times tables. 9 times 1 is 9. 9 times 2 is 18, 27, 36, 45, 54, 63, 72, 81, and 90. Just by writing the numerals from 0 to 9, 0 to 9. All right, and students are like, wow, that's really neat. And I'm like, that's not the neat thing about the 9's. The 9's, if you add the individual digits together, 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7, 3 plus 6, 4 plus 5, 5 and 4, 6 and 3, 7 and 2, 8 and 1, 9 and 0, they all add up to 9. So you'll know if you're multiplying with a 9 and your answer doesn't add up to 9, you've got an incorrect answer. All right, as we multiply, then we see that some people can do long multiplication. All right, how many of you learned long multiplication in school, where you take the first digit 3 and multiply it by each of the top numbers? 3 times 5 is 15, carry a 1. 3 times 3 is 9 and 1 is 10, carry a 1. 3 times 2 is 6 and 1 is 7. 2 times 5 is 10, carry a 1. 2 times 3 is 6 and 1 is 7. 2 times 2 is 4. And you add them all together. 5, 0, 14, carry a 1, 5. All right, that's how I learned multiplication. But then I thought, wow, this is easy. Somebody showed me you can take 235 times 23. You draw a diagonal in each of the boxes. And we're going to multiply each of those numbers by each of these numbers. So, and we can do them in any order we want. Now, we divide the boxes because if it's a single digit answer, we need to put a 0 in there as well as the answer. So everything has to be filled in. So if I don't know my 5's times tables right away, I'm going to skip over to the 2's. 3 times 2 is 6. So I would write a 0 and a 6. 3 times 3 is 9. So I would write 0 and 9. 2 times 2 is 4. 0, 4. 2 times 3 is 6. 0, 6. 2 times 5 is 10. And 3 times 5 is 15. Now, what I'm going to do is I'm going to add each of these diagonals together. All right. In my first diagonal, I just have 5. In my second diagonal, I have 9 and 1, which is 10. So I carry a 1. In my third diagonal, I have 1 and 1 is 2, 2 and 6 is 8, 8 and 6 is 14. Carry a 1. 1 plus 4 is 5. My answer, 5,405. Same as I got over here. That's called the grid method. Now there's one that I want to leave you with, and that's the Japanese method. We had 30 5 times 23. All right, so here what we want to do is we want to count all of the intersections in the separated areas. So we have in this first area over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, our 5 down and carry a 1. In our second area, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, continuing on, 12, 13, 14, 15, 16, 17, 18, 19, 20. Carry a 2. In our third area, we have 1, 2, 3, 4, 5, 6 at the top, 7, 8, 9, 10, 11, 12, 13, 14. Carry a 1. In our last area, we have 1, 2, 3, 4 intersections, and the one we carried, which is a 5. 5,405. The same answer as we got before. So I demonstrate all of these different ways that you can multiply numbers together. Some ways you multiply numbers together, you're not even looking at numbers. This is how Japanese kids learn to multiply.
Thank you, Craig, and thank you for sharing all these wonderful different tasks. I'll open it up to questions.